Somebody's got to say something.
No.
Hello. So we got to do it, like make everyone check in and say hi, or else I'm just gonna kick you out.
Hello.
Hello. Good. Right on. Yeah, people you gotta talk to me, man. It's almost worse when you guys are all quiet on here than you is when you're all quiet in lecture. This is like somehow even more creepy because I know you're there listening. All right. So who's got some questions before we get started? How are things going? How many of you guys are still working on the AdderSubtractor?
I am.
Well, I am.
Everybody else has got it done, huh? All right. So we'll keep it short now, I guess, since a lot of people are just sort of hanging out and watching if there are any questions. So what we'll go over today, and I've got it recorded on the YouTube for everyone who's not able to join us today, but we're going to take this adder and we're going to convert it into an AdderSubtractor. Now, before we get started, does anyone have any questions about the adder itself or the test bench for the adder? And if not, someone needs to speak for the class and say no.
No.
Good, thank you, Vince. All right, so there are no questions about the adder. Let's go ahead and get this guy converted to an AdderSubtractor. So what we'll do is I'm going to create a new file. I'm going to call it AdderSubtractor.v. And what I'm going to go ahead and do is I'm going to import. Now, you guys can't necessarily do this because you have to submit everything as one file. But for the sake of this demo, I'm going to go ahead and just include the adder.v file. This is exactly the same as if I were to just sort of take these modules and copy and paste them into my other module. So now I want to create my module AdderSubtractor. And we'll have all the same stuff. We'll have A, B, well, it'll be similar. We'll have select. And we'll call it R for results and a carry out. Now I don't have the starter for the assignment in front of me. Does anyone remember exactly what the parameters are for that module?
I think it's just CIN, A, B, CL, and S.
Let's take a look. Shoot. So assignments. Give me just a second, pulling up the starter file just to make sure we've got the same stuff. Hope I didn't do just those, because that's a dumb way to do it. All right, let's take a look at the starter.v for this. Downloads. Oh, I did C and AB, C out and S. Well, we'll go ahead and keep it that way. It'll all work the same. All right. Remember that your module here needs to be called top, not AdderSubtractor. Remember, top is like main in other programming languages. In Verilog, top is the main module. Okay, so let's see. Inputs, CN. How many bits are A and B?
For the assignment?
What's that?
Is it for the assignment?
Oh yeah. Well, actually, no. We're right. We're doing a different. We're doing 4 bits here, so I guess. So we need to make sure we do 3 to 0. So not quite the same as the assignment. Remember, everything's going to be the same. It's just a different size of bits. So we have 4 bits, A and B, and we have an output Cout, which is 1 bit, and an output S, which is also 4 bits for that. Now, what I want to do is take the adder, and we can actually get the whole thing done by just using the adder module that we already created. Let's see. All we have to do, adder, let's see, first is .a. So .a stays the same. It's going to attach to A. .b, we will ignore for a second. And then I should put this like over here. All right. .cn will attach to cn. .s will attach to s, and .cout will attach to cout. Excuse me. Okay, so what do we have to do to B in order to make it an adder-subtractor? Remember from the lecture on AdderSubtractors.
Put it into an XOR.
Yeah, so we need to XOR B with Cn, right? So this B, the B for the adder, is going to be equal to B XOR Cn. Now there's a chance, I haven't done this ahead of time, that this might actually break since it's 1 bit to 4 bits, but we're going to go ahead and give it a shot and see how that works. And maybe we'll have to modify this a little bit later. But anyway, are there any questions about how we set up that module? All right, I'll take that as a no. So let's go ahead and create the test bench for this module. I'm going to call this AdderSubtractor _tb.v. We need to go ahead and throw in a bunch of our boilerplate stuff. So we'll want to include AdderSubtractor.v. We'll also want to set up the timescale. 1 nanosecond / 1 nanosecond. Now module AdderSubtractor _tb. No parameters. End module. All right, reg is for the inputs, wires for the outputs. So reg 3 to 0 A, B. Reg 1 bit Cn. Wire 3, 0 for S, for 4 bits for out, and a 1 bit out for Cout. Now our actual AdderSubtractor as our unit under test. Cn AB Cout S, just like that. And then initial begin and end. We're going to try to do this without needing the waveform file. We'll just take a look at what the signals are. Kind of like we talked about with the adder, it's not really feasible to exhaustively test it, or it's not necessary to exhaustively test it. We just want to give it some numbers, see if they add up, see if they subtract, and call it good. Remember that for an AdderSubtractor, Cn equals 1 means subtract, and Cn equals 0 equals add. Oop, and I want to set some initial values in A, B, and Cn, just to keep us from getting in trouble. So the first thing, let's test addition. And let's try something simple. We got 4-bit numbers. We don't want to overflow, so let's just do 4 plus 7. All right, should get us 11. So we'll set A equal to the 4-bit decimal number 4. and set a delay. B equals 4-bit decimal number 7. We'll also delay for a little bit. We'll make sure, so Cn is already 0, but let's go ahead and just be completionist about it. Cn is equal to 0. And we delay for 20. So we should see now, if we display the output, that the first number plus the second number equals the third number. So that'll be A, B, and S. And now let's go ahead and add something for subtraction. Now let's go ahead and do 7 minus 4, which should equal what? 3. So we'll say that A is equal to the 4-bit decimal number 7, and delay for 20. We'll say that B is equal to the 4-bit decimal number 4, not 3, and delay for 20, and we'll set Cn equal to 1 to do subtraction. We'll also delay for 20, and then, I don't know why I did those inline. We'll display that some number minus the next number is equal a number, and that would be A, B, and S. And that should be enough to do the job for us, unless we screwed something up, which is, you know, always possible. I'm going to pull up PowerShell. So I'm going to do cd desktop / office hours is the folder I've got open. Make sure it's all the right stuff. Yeah. Clear. And let's see if it works. Verilog -o adder
Wait,
subtractor.
sir, did you do the dump file and dump vars?
I did not. Right? Because I'm displaying the output. So remember, you only need to do the dump vars and dump file and all that stuff if you're going to create a waveform. But you don't always need to create a waveform if you don't want to. We can display the numbers to see if we're adding. Like, I feel like displaying the numbers to see if it's adding and subtracting correctly is a little bit easier to read instead of having to look at the waveform to see if you're getting the right values. So we could go back and look at the waveform of this, but we don't need to necessarily to verify that our circuit is working properly.
Okay.
Now, as was, I think, a case in a couple of these before, we screwed stuff up and then ended up having to look at the file anyway. But for now, we're going to give this a shot. So we're going to create our simulation file, AdderSubtractor.vp from AdderSubtractor_tb.v. Now, if we screwed something up, this is where it'll happen. Hey, look at that. 6, 5, and 11 syntax errors. Invalid module instantiation. So let's take a look at line 6. Oh, that's the test bench, not the adder. The adder subtractor at line 6. Oh, we've talked about this before, but when you're debugging, notice that it said at line 6 there was a syntax error. And if you look at line 6, there's nothing wrong with line 6, but line 5 is missing a semicolon. So oftentimes a missing semicolon will throw an error, a syntax error in the line with code that immediately comes after it. So, and once we fix one error, even though there's more, it's usually a good idea just to go and check the rest of these. Yep, now line 11, syntax error, invalid module instantiation. So let's see if we screwed something up. Like I said, it might be this. But we can go ahead and test that. Let's remove that XOR Cn, right? So since we knew we did something weird, it's usually a good idea to sort of take out the weird thing. And we know that this should work just fine. Oh, you know what? I see a different mistake that I made. Does anyone see it?
Is it
Forgot
that you don't
U0.
know?
Yep, forgot to give it an identifier. Let's fix that first and see if it works. Hey, that was the problem. Okay, so now let's go ahead and run our simulation. VVP AdderSubtractor.vvp. All right, let's see what happened here. We got 4 plus 7 is equal to 11. That's good. But we got 7 minus 4 is equal to 13. Huh. Is that the right answer?
Definitely not.
Definitely not the right answer. So we need to do a little bit more exploring to see what happened. Okay. All right, let's take a look and see. Let's go ahead and do this the long way and see what we can get. So instead of doing it all in one line, what we can do is this. We can create a wire that is 4 bits long to hold the result of that XOR operation. So we'll call it W, and then we'll down here do assign W3 equals B3 XORed with CN. All right, to do the bitwise XOR, W2 equals B2 XOR CN. Assign W1 equals B1 XOR CN. Assign W0 equals B0 XOR CN. And now let's go ahead and put that W instead as our input to our AdderSubtractor. All right. So we save that. Let's go back. We're going to regenerate our simulation file and rerun it. And there we go. So it turns out my attempt to be lazy didn't work. And there you go. So we see here that we've got addition working and subtraction working. Now, as for your assignment, it's usually a good idea to maybe like be a little bit more exhaustive, maybe do a few more examples. But for us right here, this is plenty. So that's all there is to it. That's all we need to do to convert the adder into an AdderSubtractor is just add another wire to grab these XOR operations with CN and then feed those as the inputs to our adder. So, what questions do you guys have, if any?
I got a question in your test branch.
What's up?
So when you output you see the S, right, instead of C out, right?
Correct.
I thought it should be C out, or why is S?
So C out or S is the result, or it's the, I mean, from the adder it's the sum. So we were kind of lazy by calling it by calling it S both times. But that's where the real value comes from. And if you're doing, since everything is signed, really that C out is just going to be the sign bit, which is not super important necessarily to what we're doing in this exercise. So S is where the numbers happen.
Okay, got it. Thanks.
Yeah. And no, remember, so this runs on 2's complement arithmetic, so we don't need to worry about negative numbers.
So for that wire, ours will be from 7, or is it from 0 to 7, and then we just do W7 equals B7 XOR CN all the way down till we get to 0?
You bet, man.
All right, cool.
Yeah. The only thing you guys need to do to make it an 8-bit is to just add 4 more of these.
And also, should we change our, like, include the top part to, like, should we change the name of our last code we made? Because both of them are going to be our R numbers.
Okay, so 2 things. One, the module should not be your R number, right? Only the file should be your R number. The module should be named top. Just like that. And I did the include. What you will have to do is, instead of having the include, you'll need to actually have the adder stuff copy and paste it down in there just like that.
Okay.
Does that make sense?
Yes.
Cool. All right, what else?
I have a question. Can you hear me?
Yes, I can hear you.
Okay, so when we did the adder,
Uh-huh.
in your output in the test bench,
Okay.
you did this weird thing where you you put C out and S in a vector. I don't remember exactly how you explained it.
Okay, so I pulled it up right here.
Yeah.
Yeah, so we're asking about like that.
So is the reason that we don't have to do that with the subtractor, does it have to do with the fact that we're not adding an extra bit to our answer?
Correct. Yeah. Since we're working with signed numbers now, the C out is going to be the sign bit. So this sort of thing really won't work correctly.
Okay, so we only need the sum because it's going to be one less bit.
Correct.
Okay, cool. Thank you.
Yeah, I'm only going to be checking the sum. All right, what else?
When
I heard someone start a question and then got cut off.
hold on, I was trying to get used to this push to talk thing.
Anybody else? You can also type questions in the thread for this class if you want to.
Can you hear me now?
I can hear you now, yeah.
Okay, cool. So when we copy and paste that adder into our code,
Yeah.
we'll have two modules that say top. Do we need to change the 8-bit adder to just adder?
You're absolutely right, yeah.
Okay.
Yeah, otherwise it'll really freak things out. So yeah, make sure when you copy and paste that, change what was your top should just now be adder, so that it doesn't conflict with your new top that is your adder subtractor. Can't have two main functions. All right, anything else?
Going to post this on YouTube?
Yep, sure am.
Okay.
So wait, I know I showed up 15 minutes late, but where's the adder portion? Like the actual like adder portion and the subtractor portion? Because I'm looking at two things that say adder right now.
Okay, let me clean some things up a little bit. I'm gonna remove that business. So on the right hand side of the screen, I've got the adder, and on the left hand side here, I've got the adder subtractor that we just changed to top, but we can call it adder subtractor. So the adder is the adder, and here I've got the instantiation of the adder module. Now remember from the lecture, what creates a subtractor is XORing the B input with the carry in. So by creating this 4-bit wire, and for each of its bits, it's that corresponding B bit XORed with Cn, and then that wire is fed to the B input of the adder. That is all it takes to make it an adder subtractor. So that when Cn is 0, it will perform addition, and when Cn is 1, it'll perform subtraction. AJ asks, I have a question. Will your subtractor work with all adders or just the one that you created? No, I guess is the short answer. Because this is based on the logic expressions. If you're doing something weird, like if you use like if-else sort of statements, then no, it might not work because other things are happening.
these don't have to be in a specific order, correct?
What do you mean?
Like, because you said to like copy paste these like together to have them in the same file.
Right.
But, like one doesn't have to come before the other.
No. There's no. So it's called hoisting in computer science, right? There's no hoisting that happens in Verilog. It all gets validated at the same time. I could test that, right? By putting my include down here at the bottom. Yep, still works. So yeah. All right, anything else? What else?
Could you go back to the test bench real quick?
Sure. What's up?
I was just looking at it real quick. I thought I missed something.
Thought you didn't get it copied down all the way.
No, I just forgot to include the display, that part.
Well, you can't forget that, man. That's the most important part. Otherwise, you won't know if it's working.
Are you still being lenient on late work right now, or
You bet,
has
man.
that passed?
I'm basically saying all. Yeah, no, I'm not penalizing any late work. So try to get it done, on schedule, but don't stress out about it. I think I'm putting like a hard deadline for like the last day of the semester, like May 6th, to get stuff in, because that's when I actually have to, grade it and submit everything. But up until that point, no, I'm not doing any penalties. Any other questions?
So if we turn in an assignment and it gets graded poorly, would we be able to resubmit it for a better grade?
Yes. I'll allow it. We'll call that the quarantine curve. Ooh, how do we know if what we already have submitted is correct? That's a good question. So I make no promises about when I will get around to grading everything. I'll try to, since there's no due date, I'll try to stay current on getting stuff graded. Like, I'll try to have everything caught up by next week. But, I'm being flexible with due dates for you guys, so I hope you be flexible with me. And, so I'll try to grade everything in time so that you can take a look at it and make some changes and resubmit if you'd like. And I think we're gonna have 2 or 3. I haven't posted them yet, but we're gonna have 2 or 3 more assignments. So. Any other questions? Okay, well, I'm going to go ahead and kill the stream, but I'll stay logged in for another half hour or so if people still have questions. So thank you for coming, officers. I hope this AdderSubtractor stuff makes sense now. And like I said, I'll be on for a little bit longer. And so if you still have some more questions, feel free to let me know. Thanks, guys.